So today we're going to talk about the chain rule, and it's important that this comes after trigonometry because what you guys may know about the chain rule you understand to be just with exponents, and actually the chain rule is something that works for any function where you can have a function within another function. So the basic definition of the chain rule says if y equals f of u, and that's a differentiable function of u, and u is g of x with a differential function of x, then y equals f of g of x is a differentiable function. Blah, 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 blah. Here's what you need to know. When you take the derivative of a function g of x inside another function f of x, then the derivative is f prime of g times g prime. Okay, notice that the g's stay the same in here, and then we take the derivative out there. So what I usually end up saying is the derivative for the chain rule is the derivative of the outside, keep the inside, times the derivative of the inside. So first we're going to work with some exponents here. So if f of x equals 4 over x plus 1, and we want to find f prime first without the chain rule, and then the derivative using the chain rule, we're going to go through and do these together here. So if I have f of x equals 4 over x plus 1, if I go without the chain rule here, I would have to do the quotient rule. So I'm going to put a big Q for quotient rule. So I do the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. And that thing that looks like a 6 is really a 0 there. So then with the quotient rule, this ends up being, well, this is going to be x plus 1 times 0, so that's gone. Negative 4 on top over x plus 1 squared. And that's the derivative, no problem with that. Didn't even really take that long. But strangely enough, the chain rule is even quicker. So if we do the chain rule here, we're going to first think about f as 4 times x plus 1 to the negative 1. That means f prime is going to be the derivative of the outside. This negative 1 is the thing that's happening on the outside. So the derivative of something to the negative 1 is bring down the power, reduce it by 1, then we're going to multiply by the derivative of the inside. So derivative of the outside, keep the inside, times the derivative of the inside, makes this negative 4 times x plus 1 to the negative 2. Which is equivalent to what we have up there. I don't care what form it's in. If it works for you, it works for me as long as they're equivalent. All right, so the next one, 3 times x minus 1 to the second. If I wanted to do this without the chain rule, I'd FOIL it out first. So I'd rewrite f as 3 times x squared minus 2x plus 1. And then I'd probably distribute the 3 first, 3x squared minus 6x plus 3. And then I'd take the derivative using the power rule, 6x minus 6. Well, if I don't want to go through all that, I can do the chain rule instead and just say, all right, I'm going to bring down the power, reduce it by 1, multiply by the derivative of the inside. Well, if I bring down the power, I get a 6, keep the inside, reduce the power by 1, then multiply by the derivative of the inside. F prime is 6 times x minus 1, which is 6x minus 6. Same thing we had before. Now, I don't know why that's not moving over. I apologize. Now for this last one, we've got the trig. So if I want to take the derivative of trig and take the derivative of this without the chain rule, you have to remember your trig identities. Yes, they are important. No, they don't just disappear. Yes, you need to have them memorized. So if I want to take the derivative of sine 2x, but I want to do it without the chain rule, I'm going to need to remember my double angle identity that says sine 2x is 2 sine x cosine x, which I really should read as 2 times sine x times cosine x, which makes my derivative a product rule. So f is the first. I'm going to call this whole thing the first, and that the second. The first times the derivative of the second plus the second times the derivative of the first. And that's going to make my f prime. I'm going to rewrite it so that the positive's in front. 2 cosine squared x minus 2 sine squared x. And there's our nice derivative. Now, if I want to do this with the chain rule, it's actually way easier. So with the chain rule, I'm going to look at my function. I have the sine of 2x. I'm going to take the derivative of the outside. So sine is on the outside. Take the derivative of the outside, cosine, keep the inside, times the derivative of the inside. And the derivative of cos 2x is 2. Well, wait a minute. Those don't look the same, or do they? Cos 2x, if you wanted to, can be rewritten as cos squared x minus sine squared x times 2. I have to pause for a second because my dog Libby, named after Leibniz, yes, remember, I am that person. Libby needs to go potty. Hold on. I'm back. Yes, Libby is named after Leibniz. Leibniz and Newton are the co-founders of calculus, although I guess there'd be a great argument as to which did it first. So we named Libby after Leibniz because I love calculus. Okay, next page. The product, quotient, and chain rules are often used at the same time. So you need to follow an order of operations as you complete the derivatives. Now, I didn't write you need to follow the order of operations. It's just that you need to kind of follow what's happening last, and that's the thing you take the derivative of first. We're going to take the derivative of the following using the chain rule and any other pertinent rules that come up. And what I'm going to do here to shorten the notes is we've got a lot of examples down here. I'm going to go through and just pick a choice few. So I am going to first do this one, x squared plus 1 times the square root of 2x minus 3, which I'm going to really think of as 2x minus 3 to the 1/2. So if I go to do the chain rule and I need the product rule, I'm going to do the first, x squared plus 1, times the derivative of the second. So the derivative over here is a chain rule. Bring down the power, keep everything the same, reduce it by 1, and multiply by the derivative of the inside. 2. So here's the first times the derivative of the second plus the second times the derivative of the first. And the derivative of x squared plus 1 would be 2x. So I'm going to cancel these just because this is kind of begging to be rewritten here. And my derivative would be like x squared plus 1 over the square root of 2x minus 3 plus 2x root 2x minus 3. And there's your derivative. All right, I'm going to skip over this next one and come down here. The tan of sine x. So I'm going to look at this again as the chain rule. I'm going to take the derivative of the outside, the derivative of tan, which you hopefully have already memorized as secant squared. So the derivative of the outside, keep the inside, times the derivative of the inside, cosine x. And that's it. That's all you can do. And what's important to note here is this isn't secant squared x times sine x times cosine x. No, no. It's secant squared of sine x times cosine x. The next one I want to look at here is going to be sine squared theta. Now, when you do sine squared theta, you need to know that that means the sine of theta squared. And it's really important to rewrite it like this so that you remember to do the chain rule correctly. So this is sine of theta squared. So my derivative, which would be dr d theta, is going to be bring down the outside, keep the inside and reduce by 1, times the derivative of the inside, cosine theta. Okay. Down here I think you'll be okay. And h I wanted to talk about really quick. If you look at h, it says y equals tan x. Find dy dt. All right, well, dy dt means take the derivative of y with respect to t. That's not t. Well, if you're supposed to take the derivative with respect to something that it doesn't match, you're still going to follow the chain rule. So it's going to be the derivative of the outside. Derivative of tan would be secant squared. Keep the inside times the derivative of the inside. The derivative of x we would write as dx dt, just because we don't know the derivative with respect to t, so we're just kind of saving that for later on. This step will make a little bit more sense when we talk about implicit derivatives. Now let me check my time here. All right. Now, if we jump to the back, on here, a lot of these we've done before. I'm just going to pick a choice few to go over, the ones that have to do with the chain rule. So we're going to use these things at the top to try to evaluate the derivative of f at 5. So find f prime of 5 if f of x equals g of h of x. So the rule is if you have a chain rule g of h of x, which is different than g times h, g of h of x has a derivative that uses the chain rule. F prime is the derivative of the outside, keep the inside, times the derivative of the inside. So if I want to do f prime of 5, I'd have to do g prime of h of 5 times h prime of 5. So this is going to be g prime of h of 5. H of 5 happens to also be 5. It's like I planned it. Oh, wait, I did plan that. Then time h primes of 5. H prime of 5 is negative 2. All right, so now I need g prime of 5. All right, what's g prime of 5? That's 6. Times negative 2 is negative 12. Da-da-da. Chain rule at work, you need to know the notation. You'd have a product rule and a quotient rule here. We'll practice those later. The other one I wanted to look at was down here, g of x to the third. This is another chain rule. I'm raising a function to a power. So when we take the derivative, f prime, we're going to bring down the power, keep the inside, reduce it by 1, and then multiply by the derivative of the inside. Oops, that meant to be an x right there. So if I want f prime of 5, I'd need 3 times g of 5 squared, g of 5 squared times g prime of 5. And let's see, what was g of 5? I don't remember. G of 5 is negative 3, g prime of 5 is 6. So 3 times negative 3 squared times 6 is going to be 54. No, not 54. 3 times 3 squared is 27, pardon me. 27 times 6 is, well, 27 times 3 is 81, times 2 is 162. All right. Beyond that, I'm going to stop here because I think that's enough talking for me to do the chain rule. So here's what I'd like you to do. Before you come to class tomorrow, I'd like you guys to do the other examples in this worksheet and then come to class ready to talk about them. So anything we didn't go over here, do on your own, and then come to class and we will chat. I will talk to you all soon. Bye-bye.